Welcome to the Test Set. Here we talk with some of the brightest thinkers and tinkerers in statistical analysis, scientific computing, and machine learning, digging into what makes them tick, plus the insights, experiments, and OMG moments that shape the field. On this episode, we chat with Roger Peng, author and professor of statistics and data science at the University of Texas at Austin. I'm Michael Chow. Thanks for joining us. Welcome, everyone in the world. This is the Test Set, a podcast where I'm joined by my fabulous co-hosts, Hadley Wickham and Wes McKinney. And today we're here with Roger Peng, professor at the University of Texas at Austin, and prolific course creator, podcaster, and researcher. Roger, do you mind telling us a little bit about yourself?
Sure, yeah. So I'm a professor of statistics and data sciences at UT Austin. I've been there only about 3 years, actually. I used to be at Johns Hopkins University in the Department of Biostatistics. And, like you said, I do a number of things. I do a little bit of research, primarily kind of developing statistical methods for environmental health problems. But then I've also developed a number of online classes, developed 2 podcasts, and written a couple of books. So yeah, general content creator.
Yeah, awesome. Yeah, and we're so glad you came. Like, we hit Roger up kind of last minute, and Roger was like, I'm there, hop in the car, getting the band together.
That's right.
And I think it's super relevant because the Test Set is it's a little baby podcast right now, and we're feeling out sort of how baby's first steps into podcasting. We've got some really great people, and we feel like there's a lot of chance to kind of look at the people behind the data and the landscape. But with you as a kind of like grizzled podcaster, I think you've been doing a podcast for like 10
Something
years?
like 10 years, yeah.
Yeah, nice. Not So Standard Deviations.
How many episodes?
186, I think, at this point.
Incredible.
Yeah.
Yeah, I think we're really excited to hear your take on like why podcasts exist and how to make them nice and what to do. But I think maybe to start out, it'd be really interesting to hear maybe some of your background in data too. Like, what was your very first data analysis?
Oh, wow. That's a good question. Yeah, and I have to go back pretty far now.
Yeah.
Every year it just gets harder and harder. I think one of the first data analyses I did, which actually is the reason I started using R, actually, was I was doing like a project, in school and looking at different like texts and trying to be able to develop a way to kind of identify who wrote which text, like author identification, using just discriminant analysis, very basic tools. And so there's like some text processing, there's a little statistical modeling, and it was all done in R. Yeah.
Oh, nice.
Yeah.
And when was this?
Oh, wow.
Or what stage of life?
Well, I can tell you, it was R version 0.65, something like
Wow.
that. Yeah, it was like 97.
Two people speak in R stages. That's
Yeah.
good to know.
Did you use anything before R? Like, were you?
Well, so I was a
yes.
S plus user,
Yeah,
for
okay.
sure. Yeah. So, but like S plus cost, I don't know, it was like hundreds of dollars.
Yeah.
So
Yeah.
and I was looking around for a free alternative, and in the Yahoo search directory, R came up.
Incredible.
Yeah.
Do you mean you're searching? You're like free alternative to S+?
No, well, you didn't really search in Yahoo,
Okay.
because it was like you click on a link and then you click on another link. It was like
Yeah.
a directory kind of thing,
Okay.
and you click on it. It was like free software, statistics, something, and then eventually there was like a couple of options.
Yeah, you like went down a series of pipes. And
Exactly. Yeah, there was
landed
no
it.
like searching. Yeah.
Wait, that's incredible.
Yeah.
Wow. And do you have any advice you'd give students today trying to get into data science?
But yeah, so I also find that I get that question a lot, as you might imagine. I teach a lot of undergraduate students, and they're interested in data science, and it's always a little weird for me because I kind of feel like for me, and I don't know, maybe for you, Hadley, like data science happened to me. Like I don't feel like I got into data science.
You mean like it tackled you, like
right? Yeah,
on the street?
Yeah, more or less.
Yeah, like I double majored in computer science and statistics,
Okay.
which is a weird combination.
It's like alchemy.
Yeah. And so I did statistics. I got my PhD in statistics, but I just happened to really enjoy programming. I took a lot of CS courses in college, and I just really enjoyed programming. And I think it wasn't immediately clear that would be useful. In getting a PhD in statistics. So I think, so now that data science has happened, people kind of assume, especially the students that I have, they kind of assume it's been around forever.
Yeah.
And so it's a little tricky. But I think I mean, one of the things I generally try to tell them, especially at an early stage, is kind of like is make sure that you can have some way to show people, that what you've done, like that you've analyzed data, that you've been able to like, ask a question, draw some sort of even basic conclusion from the data you've looked at or from the work you've done, and then kind of go from there, and then kind of see if it interests you. If that kind of doing that doesn't interest you, then it's a good sign, Then you'll know early. But
yeah, it's really interesting to hear about students, the value of producing a report to see how it feels for you, and like having something, kind of the whole process to put out for other people.
One of the things that I think is a little different now is that there are like a lot of programs that you can go into and maybe get a certificate or get a degree or something like that. And I'm always a little hesitant to, even though I teach at a program, obviously, I'm always a little hesitant to say like, oh yeah, go get a master's or go, because that costs a lot of money. And if you don't want to find out you hate doing this,
Right.
So at least, but now it's pretty easy to get data. There's a lot of data around. There's a lot of things that you could try. And I think if you could try it and find out that you enjoy doing it, then it's maybe worth investing a little bit more.
Yeah, that's fair. It's interesting to hear too, like where you two mentioned, like getting basically like data science. I think you said like came to you, like where you did like stats and computer science, and that kind of like added up to, or somewhere in that space, you hit data science that like there was less, I guess, like sampling, like trying out a report, and where students today kind of have this actual program and can kind of quickly figure out like, is it for me?
I mean, even the term, like the field of data science is, I think as recently as 15 years ago, that term didn't really exist. It was almost like a marketing term to describe doing statistical computing or data analysis in a business setting. So like some combination of like programming and data analysis combined with reporting and communication, and then combining that with domain knowledge about some business domain, the famous Drew Conway Venn diagram. And then suddenly, it became so popular, and also there was this big shift toward open source. And then every university needs to have a data science program because students are arriving and they're like, well, need to learn how to do data science because that's where the job opportunity is. Like there's a great need for more data scientists in this industry. And so it seems like universities have had to respond by reorganizing themselves to create these cross-disciplinary data science programs to pull together statistics, computer science, and maybe political science and economics and other fields that cross over into because you have statisticians that live in all these different departments, but they do statistics within these domain-specific settings. But there's a lot to be gained from making all of those different research specialties accessible to undergrads and master's students and PhD students who are building skills in that area.
Yeah. I think it's been interesting to see just kind of how that has evolved at various universities, because there are like I said, there's lots of people analyzing data all across different areas, and they're in different departments usually because they're looking at different kinds of data, like psychology or economics or whatever. So it's a little bit of a challenge, because then you want to put everyone together. You have to think about like, well, what is the unifying principle? What is the generalizing kind of thing? And I think a lot of times it's software. So it's like there's lots of different places that you can analyze different kinds of data. But in other areas it might be like theorems or whatever, laws. But I think in data science a lot of the unifying thing is software. It's like we can use a piece of software for so many different things. That's the generalizing kind of element.
Yeah, that's an interesting.
So do you think there's like more respect in academia for like developing software now compared to like 10 years ago or 12 years ago when I left?
Yes, I think, yes, compared to 10 years ago, there's definitely, whether that's enough, I don't know, but there's definitely more, I would say, than, compared to back when you were there. I think one of the challenges, I think, with academia and software is that, academia to this day, I think it's set up to discover things. It's not set up to develop things or maintain them, for that matter, and I think, and if you think about what a paper is, it's like you discover a fact, you write a paper about it. You don't have to maintain that fact, right? I mean, for the most part, and so you can just let it go and then move on to the next one. And it's not how software works, obviously. And so it is a challenge in that environment, I think. It's
kind of interesting to think though that like maybe more papers, like if you had a more of a maintenance approach to papers, like maybe there'd be like less of a reproducibility crisis. Like you can like update.
Yeah, or if you were like allowed to go back to it, and check out.
Like, oh, actually, we're kind of like not so sure about this.
Yeah, I'm super curious where we're kind of kicking off a podcast now about data and data science, and you have like 10 years of doing kind of podcasts, and then earlier than that, like Coursera courses. Yeah, I'd be really curious to hear from you. Like, what do you think is like the secret of a great podcast?
If I knew that, I'd have one. You know?
I think it's pretty baller, you know?
I don't know for sure. I don't know, and I think that question can be asked, you know, from two perspectives. One's from the audience, and one is from the actual like podcaster, right?
Yeah, like who's it for? I guess.
Yeah, yeah, and also like, you know, what are your goals at, you know, developing the podcast? Do you want it to be something, you know, from my perspective, I want it to be something that, you know, I have a job, I have all these things that I'm working on, had to be kind of easy to do, fun to do, but still kind of have some sort of useful product at the end of the day. And so it's, you know, it's very minimal setup, you know, just recording over the internet. And so, and you know, not too much prep. You know, the other end of the spectrum, you got like these narrative podcasts where everything's scripted and everything, you know, and you know, that's a super expensive way to do things, but you get a really amazing product at the end of the day. And so then everything else is kind of in between, I think. Personally, I like listening to conversations between people that are like kind of deep and kind of involved, and where there's like a relationship there, and kind of people, and they can just time to move into like to do more than just scratch the surface. But that's just my personal thing, and that's kind of how I modeled the two podcasts that I built.
Yeah, that's really interesting. I mean, for some context, so I think we mentioned like Not So Standard Deviations. It's been going like 10 years, and you have over 180 episodes. How did that kick off? Like what led to Not So Standard Deviations?
So I mean, I think I've been listening to podcasts, I mean, probably since the early 2000s, you know. So like when they first came out, and I've always enjoyed, most of those podcasts were like tech podcasts for the most part, you know. And I think I always felt like there at the time, which was like 2015, I didn't feel like there were too many podcasts where you could just, a couple of data scientists just talking about stuff they're doing. Just very informal, very just kind of casual, and there were a couple of things where like, you know, there are a lot of podcasts where like, you know, today we're going to talk about linear regression, and then tomorrow we're going to talk about random forest or different techniques and different software packages. They were more like, for lack of a better word, instructional, and I think I wanted to just have like, imagine just like a hallway conversation between two data scientists in some place, you know, and that's kind of like how I wanted it to feel. I don't know, whether I achieved it, I don't know.
And I think it really shines through like the responses to things and like what people are up to and getting takes. It's like your co-host Hillary Parker, like I do feel like my take, and this might be wrong, it's like 70% Hillary's going, you know, what's latest news and views, hot takes, and then you're like, or you're like, maybe, or like complicated.
It's minimal work for me, I would say. But, one of the things that's actually been quite interesting, I think, is that she's, you know, changed jobs a couple times, you know, which is, I think, is the norm in the data science industry, and so we've been able to like kind of take a little tour of like what the different kinds of things that can happen in different companies, and
cool.
In the data science world.
Oh, nice. And did you approach her? Or did she approach you about the podcast? How did you?
I approached her.
Okay.
So our connection, she graduated from the PhD program at Johns Hopkins. And then we kind of lost touch for a number of years, and then I think we reconnected at like one of these R Open Sci kind of unconferences. I think it was in the GitHub headquarters. And I just kind of, we were chatting at that time, and I kind of just proposed the idea.
Oh, cool.
And
and is it?
10 years later.
Exactly.
Just cooking. Do you are you like keeping a log of topics? Like, how are you hitting stuff, or are you texting latest news? Like,
there's a little bit of that, a little bit of the latest news. There's a little bit of like, let's take a topic and just kind of go deep that we choose on our own. We've had a couple episodes where we'll like read certain books or something like that. But it's I mean, I try to keep for better or for worse, I keep the prep to a minimum, just because I don't want to take over my life. But usually, especially nowadays, there's always stuff happening in the news and, you know, whatever. So
I mean, there is an interesting tension between like, you know, kind of burning brightly for a short amount of time versus like that sustained, like if you want to do something for like decades, then you can't like kill yourself putting together every episode. Like it's got to be sustainable.
So, and I think that's true for so many things. Like you look at blogging, you look at YouTubing or whatever, anything like if someone's been doing it for 10 years, it's got to be like a sustainable kind of like manageable approach. Yeah.
That's a good point. I mean, it's interesting parallel too between the like papers versus software. This like big that you kind of like go and publish and then like drop the mic.
Right.
Versus software where you're like chipping away for
only
like
people
decades.
are using it.
Yeah. You're chipping away
Yeah.
or you like quietly disappear and kind of like close the door.
How do you,
Yeah.
I mean, how do you think your listener community has shaped the podcast? Like, you know, positive feedback, negative feedback, and like I find that, you know, from having, you know, worked in data science tools for the better part of 2 decades, like fads come and go. There's like always like the things that are in you know really hyped and everyone talks about and wants to hear your opinions on. So there must be a little bit of like, you know, talking about the things you want to talk about, the stuff that's interesting, but then also maybe hitting on some of the, you know, flavors of the week or flavors of the month that are like on everybody's mind.
Yeah. I think you have to. There's got to be some blend of that. You know, we don't have really any data on our audience. We don't really collect any data, which I think is good for the most part. And I think, but my suspicion, just from the feedback that we get, is that it has kind of like turned over a little bit, you know, over the last 10 years. And so it's not like there are maybe some people who are still listening from 10 years ago, but probably not that many. And I think, because I think like we try to, it's maybe a little bit more attractive to somebody who's like starting out, just to kind of hear this kind of stuff. But yeah, so we do have, there is an element of like keeping up with the latest things, even if I don't use them, and just kind of having understanding how they work and what they do.
Yeah. Do you feel like it's more, is the podcast more for you or more for the audience, do you think?
That's a good question. Yeah. A little of both. I think doing it for us has been really helpful.
Yeah.
Just to think through ideas and yeah, actually some of the stuff that we've talked about have, you know, over time turned into papers, for example. So yeah.
It's almost like, I mean, it almost strikes me as like pair programming. Like you've spent 180 hours or episodes, which are like almost an hour just like working through something with a person. It's like kind of interesting. You're like pairing on the topics of the day.
Yeah.
Did you say how you got started with the podcast with Hillary is you kind of ran into her at a conference?
Yeah,
An
basically.
conference.
Yeah, nice. I realized like it might be good to loop back to how y'all know each other and like the places y'all know each other from. Like, is it conferences? Is it like cryptic R mailing lists?
Yeah.
Like,
Where did we?
I think it might be something along those
please
lines.
let it be cryptic R mailing
Like,
lists.
at least initially.
Yeah.
I think I might have responded to one of your early R like mailing list posts, and then also in academia, there's kind of like a network of it's a pretty small world of statistics.
You kind of see.
You hear about people, and then
user.
Yeah, nice.
I'd actually never met Roger before today.
Yeah, we actually
I was in statistics. Like I was a PhD student at Duke before I dropped out to work more on pandas and do entrepreneurial things. But I had met Hadley in early pandas days. He invited me to give a talk at Rice Statistics, which I think was maybe 13 or 14
years
ago, something like that.
Yeah, that's wild. It's way back.
I mean, I've known about Wes forever, but it's nice to be able to finally meet him.
Where are like the places that a lot of the kind of like development and the conversations happen? Like how much of it's happening at like conferences or other places?
I mean, there's a surprising amount of things that come out of conferences and like the hallway track. Mm-hmm. And maybe there's something you're thinking about, and just when you're together with like birds of a feather, they have these, birds of a feather want to talk about, I don't know, data visualization or data frames or, data access and different things. And, you'd be surprised how many times that just like a casual conversation turns into like, hey, we should do something together. We should start something. And so like, I know like, Hadley and I created a, file format called Feather based on just like Hadley was visiting. And I said, hey, I'm thinking about this new thing called Arrow. I'm like, it's like, why not? How hard could it be?
File format speed run.
But that was also like, I think especially during COVID, like we all realized like how difficult it was to be deprived of having those serendipitous in-person reactions with people at conferences and meetups and things, because all of a sudden, you have to go out of your way to like, that bumping into somebody at a statistics conference or at a data science conference, like suddenly those interactions are not happening. And so, so for me at least, like that's been a rich source of like inspiration and new ideas and new collaborations.
How often is it like a friendly collab conversation, like, oh, I love your work, versus like strong opinion, hey, I got a bone to pick, like, ooh, we got to get this package sorted
people
out.
People are almost always pretty friendly in person. Like I've got a bone to pick things are
it's
always like like email or
we're all hiding behind
Twitter.
masks.
Yeah.
I mean, or at least in my experience, if it is like that, it's for like 5 seconds. And then it's like, okay, let's just have a conversation about whatever, and then you can often sort it out, I think.
I do feel like that does kind of remind me that in-person conferences are kind of like a nice balm sometimes, where like, you might interact with someone online and they seem like kind of intense or mad, but like getting in person does feel like it kind of like softens
but I guess there's still like especially like academic conferences, like the questions at the end of your talk can be like, sometimes they're pointed or they're like, this isn't actually a question, I'm just going to talk about what I'm working on.
Right, exactly.
Like a lot of one-upmanship and
Yeah, that is an important point that I guess I wasn't thinking of academic conferences at all, where I do think the intensity lingers on even after the talk sometimes.
Yeah, but there is still that hallway element, like I think conferences are useful if you've got like ideas kind of cooking in your head for a while, and then you see someone who like, mentions the same idea, then you just get a little validation, like, oh, maybe there's something to this,
Yeah.
I do think there's like something about travel as well that just kind of knocks you out of your day-to-day routine and like makes you think about, and then like a bunch of new ideas, and even if you're not really necessarily paying attention to like all the talks you're in, but there's just like something about like jolting you out of your like local minima of thinking.
Or like plane coding. Do you all ever do like coding on the plane speed run? Like, I have X hours. Will I complete this package in time?
I don't know. It's like so dependent. Like, I don't know. It's very difficult for me to program without good internet now. And I feel like planes, it's often like the maximally worst internet. Where if it's like any worse, you just give up.
Right.
But you're just on that cusp of
Just
like, for like 4 hours, you're like struggling.
We've got to put you on a train like an Amtrak, so you have like 30 hours with internet, but you're still trapped.
I've definitely had my fair share of productive plane hacking sessions, but it's funny now, like so much of development is, as Hadley said, has become internet dependent, and of course like none of your nice like AI auto completion and tools and whatnot work well. If there's no internet, or if there's bad internet, then it just ends up being a bit frustrating. Like I, to make sure that I've pulled from, like I've git pulled before getting on the plane, because I've definitely forgotten to do that. Like make sure I build and like download all the dependencies.
Or like load up like 7 tabs of the issues you want to work on. Just in case.
I do that. I do like that, like stashing away, getting ready for the plane. Since we have you all here, I thought this was the perfect time to broach the podcast question: R versus Python. Is this the only time we should ask this question?
I don't know if that's fair, but we'll see.
I don't know. Like I was talking to Hillary last week, and she's like, "We're post-language."
We're post-language.
I completely agree with that. And I think Hadley and I have like kind of been on the same page about that for a long time. Just that the language wars are not productive, or at least like I think we've reached a point where we've established like a basis of. Like there are certain things that where we figured out how to share technology between the Python and R worlds. Like we built Arrow, and like that was like a many-year endeavor. And now there's DuckDB, and you can use that. And of course now like we're using all these services that live in the cloud, and so we can use those portably. But it's also interesting because I think like Python and R, like at one point it seemed like they were in direct competition with each other. Maybe like the early 2010s, like Python started to become popular in a business setting for doing data analysis and some data science type work. There were some new open source projects for doing statistics and some of the work that you would do in R. You had some data visualization, still not as good as R. Even today, still not as good as R, I would argue. But I feel like at some point, maybe in the mid 2010s and like certainly, more recent times, like Python world has diverged a lot more into like analytics engineering, data engineering, AI engineering, machine learning engineering.
Yeah.
And so in a sense, like it feels like where Python was in terms of like statistical computing and data analysis hasn't evolved that much. Whereas like I still wouldn't, if you're doing, coming from SAS or SPSS or like a commercial statistics language, like R is if you want to be open source, like R is the thing to use. I think R is the thing to use regardless for that, for that type of work. But certainly in open source, whereas the Python ecosystem has gone in kind of a different direction, and it certainly has become like, the scripting and automation language of AI.
Yeah, for sure.
But like the conference that Wes and I were at last week, the language that everyone was talking about was SQL.
Oh, interesting. Okay.
Like that was like by far and away more people talking about SQL. Like like SQL seems to be having like a resurgence right now over the last few years. Like that's
like we're asking R versus Python and SQL's laughing.
Yeah,
all
like
the way to the bank.
40 years later. Yeah, it's like it's my time. Finally.
Do you feel like do you think that SQL is seeing a surge of popularity, or it was like already there and we're just sort of like
noticing it now?
Noticing it.
Yeah, I mean, I think it's just been like steadily. It's just like this layer that underpins all data activities is like SQL is there. Yeah. And my feeling is like it always will be there. In like 100 years time, people will still be running SQL code. Like we're stuck with it like forever.
Yeah, that's fair. Any advice? I know we asked Roger advice to students. Maybe it's a good time to also turn it to you too. I don't know how.
I'd like to hear it, to be honest.
All right. Any advice to students learning data science today?
And I have to say, it was really interesting. Like, I think Roger's advice was mostly like, learn if you actually want to do data science, which like thinking about like, like when you're a student, like you've got no idea about what is actually appealing to you. So I think there's like part of it is like finding out like what like really resonates with you, and part of it is the sort of like optionality, like making sure you're trying to keep your options open so that you can get a job and earn decent money and still consider still be able to find out like what is it that you like really care about. So I don't know, to me it's about like don't get like too locked into like one path or like one vision for your future, but make sure you're like taking, these weird and wacky courses that, maybe sound like something you're not be interested in, but might turn out to be that's actually the thing that like drives the rest of your career. So.
Yeah, that's a good point about kind of discovery and feeling it out.
I mean, I have to think that now if you were, 17, 18 years old, an undergrad entering and wanting to become a data scientist, that the path now is probably, radically different, not just like what it's like to, go from not knowing R, not knowing Python to, it's like, what does it mean to now master a programming language in the age of LLMs, where in a sense, like you want the, AI tools to help you automate away a lot of the boring stuff. Like you would have to learn all of this boilerplate and, stuff that frankly was getting in the way and the higher level thinking, like actually thinking about the data, actually asking questions and engaging in more of like the scientific reasoning process. And so you would have to like learn how to program and learn the mechanics of writing code and all of the, package management and environment management and the nuts and bolts of doing that. And so now we can rely on AI autocomplete and LLMs and agents and all those things to write a lot of that boilerplate for us. So one optimistic view is that that it will allow students to focus more on like the scientific reasoning and knowing like what are the right tools to use and like how can I give the best quality feedback to the AI code generator. If you don't know which models to use, and like I guess there will be certainly a lot of data scientists who are just going full vibe coding, letting the LLM do all the work, and they look at it, they get a nice PDF document or a markdown document at the end, and they're like, looks good, looks good, send to boss. But I think that it's still going to be important for data science. Like there needs to be a human in the loop to like be able to judge the output, to say like, is the LLM doing the right thing? Does this analysis make sense? Is it asking the right questions? Do we need to ask more questions? And so I think I have a more optimistic view that it's not like AI is going to eliminate the need for data scientists, but it is going to I think it's going to require people to get better at the actual data science, and maybe developing advanced programming skills, I think, is going to become less, maybe on a relative basis, less important.
Yeah.
That's actually my hope. I don't think we're quite there yet. So we're kind of in a weird in-between stage, I think, right now. But I think what you said highlights, I think there's like aspects about doing data analysis and looking at data that are difficult to really kind of quantify or really understand. So it's like, it will really highlight that there's a lot of things that we don't know yet.
Yeah.
And because the easy stuff, which is really, or so to speak, the programming, if that's all, taken away and we don't have to do that anymore, then we have to like actually think about data, and that can be hard.
Yeah. I have to say, like, I'm sort of, I don't know, I'm optimistic about this idea that human plus AI can do better than either alone. But I would still say, like, if I was a student today, I'd also be making sure there's something I can do, like, that AI cannot, like something with my hands, like just have a backup plan.
You're
just
going to like manual
physical.
dexterity as job insurance.
Yeah, or like human to human interaction. Like, I don't know, that just feels like I'd be like, just to make sure you've got like a backup plan.
Yeah, that's a good point.
Make sure you can shoot a gun and dress game.
Just stock up on tacit knowledge.
What they say.
Yeah.
Grow vegetables.
There's somewhere 10 years down the road, someone's going to say, when did you become such a good hunter farmer in this barren strip of some state? And they'll be like, oh, I watched this podcast.
That's right.
Well, like the Jedi meme, it's like, a person of your skills, why, be a farmer. It's a simple life. So.
Jeez. Are there any communities like in data science or kind of around the ecosystem that you're most curious about? Just to inject one, I've like DBT, I think, is a really interesting, like, wherever SQL people live, I find, is a really interesting.
Yeah, we were just talking about SQL. Well, I think it's interesting that, I guess the emergence of Python as the mainstream business computing and data orchestration and automation language has brought a lot of work that was taking place in like proprietary tools and by stodgy database administration tools, has brought all of that into the land of open source. And so DBT is taking on the role of enterprise ETL, which used to be done with all these products that people bought that were really expensive. And people still had to build, 30 years ago, people were still building data warehouses and they had much smaller data sets. There wasn't, what we now think of as big data, but they still had to design schemas and architect the data warehouse. And people would spend their whole careers just architecting Oracle databases, designing things for performance, so that work has always existed, but now there's hype, sort of really hyped up open source projects that everybody's scrambling to learn because new companies are being founded all the time and they need to say, okay, what's my analytics stack? How do I go from collecting data out of my mobile application or my website to I have a data warehouse where I can run a SQL query and build a dashboard. And DBT has become one of the, sort of mainstream technologies to make all that work. You need a lot of other pieces, of course, in the pipeline, but as far as the semantic layer of how do you describe what's going on, what queries are being run to generate the final product. I've never actually used DBT directly, so I will admit that. But I've been following its trajectory, and I think it's definitely very interesting. It's not data science. It's analytics engineering or data engineering. But because it's adjacent to our space, it creeps up, and it's not uncommon for people doing data science to incidentally say, oh gosh, I have to learn how to do DBT because I don't have the data that I need, and in order to have the data that I need reliably for my data science application, I need to set up some DBT workflows or pipelines so that I can deliver this data science application.
Yeah, that's a good point. It is an interesting case too, the R versus Python situation, and the what is data science, and the kind of role that DBT's carved out with analytics engineers. I know one infamous talk, which I think is pretty tongue in cheek, down with data science. It's an interesting kind of like comparison there to like analytics engineering versus data science as kind of like roles in the ecosystem.
I think that I feel like that's really changed a lot over the course. Like when I started doing data science, like you were the data engineer.
Right.
Like
Yeah.
the data would be in like, oh, here's like 100 CSV files in this directory, and here's a random API, here's a SQL database. Like your first job as a data scientist is just to get the data into a usable form for you.
Yeah.
And I think that's no longer so much the case. There's still like challenges, but that's much less of a challenge now than it was 10 years ago, which I feel like a little sad about, because that's like part of the job that I like love doing, like collecting data sets and organizing them. And
Yeah. Roger, do you see much interest in like analytics engineering, or do you see it show up much with students?
I'm not 100% clear that they necessarily are exposed to that kind of work, or that they necessarily or would be aware that it exists. I think, but I think as we talk, we teach them data science, and as they get to understand like what are the different components that are involved, and how do you get data from A to B so that you can analyze it. They eventually I think they get an understanding of why you need something like that.
Yeah, that's fair.
I mean, there's probably like a fair amount of like, I hesitate to call it bait and switch, but like, students are getting recruited into these, data science type roles, and then finding that the actual work that they're doing is they're maybe doing a lot more ETL and SQL and data engineering than they expected. I know that certainly happened to me. I got a degree in pure math. Like this is before I did statistics, but I was working for a quantitative hedge fund. And I got so excited, like, gosh, I'm gonna be doing modeling and like working out equations and like applying math in the real world. And I sit down the first day, it's like, okay, here you go. Here's SQL Server Management Studio. Microsoft SQL servers over here. A lot of the work was like data quality, like data cleaning, data like really, but it's quality, like having good quality data as inputs to your data analysis process is essential. So I think there was some initial shock of like, gosh, like I'm spending all my time like, monkeying with stored procedures and looking at Excel, data quality reports. But then, if you don't have that, it's like a little bit like if you haven't got your health, you haven't got anything.
Right.
And so,
There's a little bit of that, I think, everywhere. Like in the academia, I think it's just kind of the same thing. They think they're going to be doing all these like great scientific theories, and then at the end of the day, it's like you're merging CSV files and you're going through Excel spreadsheets or something like that.
Right. But I think a lot of that too is like to be useful. Like you have to not be too constrained by what you already know how to do. You have to like look, when you're faced with a new problem, be like, well, like where's the value? Right. And like, what do I need to learn in order to be good at this, rather than thinking like, these are the 6 things I know, like how do I apply them to this situation?
Yeah, I think one more question for y'all. What do you think has been most impactful from your work? And what excites you most about data science?
Now that it's actually in many ways a lot easier now that I've been doing this for quite a long time, like 20, 25 years-ish. And I can see, like, one thing I can see is that impact often takes a lot of time to kind of unfold, but it does happen, and so I think it's easier for me to justify to myself, like, why am I doing this? Because I have seen some impact. Things like environmental policies, changed because of the research that we've done, or things like that, and also some of the online courses that we've built. You have like millions of people who've taken these courses. I've met them in person. They say they've gone into data science or whatever. So that takes a huge amount of time. That doesn't happen tomorrow or overnight, and it takes a long time for it to unfold. But then it does happen, and it's really rewarding, I think.
Yeah. It seems incredible having a long kind of like time horizon to really like let that stuff grow and appreciate.
Yeah, I think it's hard to do when you're starting out. You kind of have to just believe that's going to work.
Yeah, that's really neat. Wes, any thoughts?
I mean, I've really enjoyed just expanding access to technology, like to open source technology. So building open source projects, and then creating technical communication. Whether like I wrote a Python book. I haven't written as many books as Hadley has, but Hadley enjoys writing more books than I do, it seems.
More than most.
But so having now it's been, I think Python for data analysis came out 13 years ago, and Pandas has been around for a few more years than that. And so I think for me the most satisfying thing has been hearing from people all around the world about how their path to, discovering Python, learning language, learning how to use pandas, and the impact that it's had in their lives. And so, hearing from people in like really humble circumstances about how they were able to learn these tools and it got them their first job, or is like really essential to the way that they work. In the past, like a lot of computing technology was hidden behind a paywall, essentially. So you had to buy a license to a piece of software, and for many people that was a practical barrier to learning and to being able to use those tools. And so I think having free software available, anybody with an internet connection, and now computers have gotten a lot more capable, and so so people all around the world can use these tools to empower themselves and change their lives. And I also find that building like these the open source communities around them, and building communities that eventually run themselves, so that you can step away and think about what's next. I think has been really, really satisfying too. And I like seeing people more productive, and so seeing that has been pretty exciting.
Yeah, it's really incredible. I mean, I think you mentioned too before, I think Pandas, you said, is 17 years old?
2008, yeah.
Yeah, wow. Okay. So it's powerful to hear both of you talk about sort of this time scale, where I'd imagine a lot of people cobbling a tool today are not thinking about like 17 years from now. It's really...
Yeah. I mean, I think I always was just thinking about tomorrow. Like I want it to be better tomorrow. And so, thinking about years from now, I mean, of course, if people find it useful and they use it, then that's great. But often like the motivation is, the problems that are right in front of you and the things that you see are not good now. And that like, if you perceive that you have the ability to like, whether it's, writing something that helps people learn or making the software better and solving a problem that's annoying you, then it's really satisfying to see that through and to get it in people's hands.
Yeah.
Thanks.
Yeah, I mean, I do think that is like one of the positive things about academia. It's like that more of that like long-term time scale. Like things don't have to, like you don't have like a deadline on next Friday to get this done. That things can take like months or years to do, because it does feel like that, like the impact you have, it takes like a long time to build up and to like really know what the things you did, like what were the actually impactful things that you did. And I had a few conversations again at this conference we went to last week. Like I kind of like to think like it's my code that's most impactful, but I talked to a lot of people that maybe they used R and enjoyed using ggplot2 or the tidyverse, but like what stuck with them was like the underlying ideas, or some of them like I was just like kind to people when they like talked to me like 10 years ago, and they're like, oh, I still remember that. And that just feels like just kind of like reaffirmed to me like, that I had made this deliberate choice. Like I had some like negative role models of like, people higher up in their fields who were like, I did not have a good experience with. And I like very deliberately, try to be like, kind and patient to people regardless of, like how much they know about the field. And that just feels like over time, like that's increasingly valuable.
Yeah. Yeah. It's really
impactful.
It's really amazing to hear it circle back like 10 years later that somebody might still be kind of carrying that and thinking about that.
Yeah. I mean, it's also like scary when you think like, oh, I've had a bad day and I had a bad interaction with someone, and are they going to remember that like 10 years later, like when Hadley said something really mean to me, and like, like you don't hear the people who are like, I'm leaving data science because of Hadley. Like I never hear from those people. So.
Yeah. Well, thanks. Yeah. Thanks everybody so much for coming on. I mean, you two are part of the podcast, so thanks. Me, I don't know.
Thanks for doing your job.
Yeah, definitely thanks, Roger. 100% thank you, Roger. But no, it's been so helpful, I think, and incredible just hearing about the field of data science and your interactions with open source over the years and how that timescale can be really long. And I do think that's one really neat thing about this podcast is the opportunity to hear kind of some of these long-term projects or like the histories that brought people to where they are. And so just really appreciate you being here and taking the time to come down.
Yeah.
And The Test Set is a production of Posit PBC, an open source and enterprise tooling data science software company. This episode was produced in collaboration with branding and design agency Agi. For more episodes, visit thetestset.co or find us on your favorite podcast platform.